to the post-lunch Friday session. Glad you're all here. And we're going to talk about Declarative Gradle on Android. So we're going to talk a little bit about the challenges. That's right, challenges in Gradle. We're going to talk about developer first builds. We're going to have some demos. And then we're going to talk about what's coming next. Before we get started, just a little bit about us. So I'm Nelson. I'm actually formally working at Gradle. I no longer work there, but I'm giving this talk because I am very excited about Declarative Gradle as well. And this is Inaki. Inaki is still at Gradle. He's on the solutions team. And yeah. So a little bit about Gradle. Since 2008, our mission, I'm going to use R and we to refer to Gradle and myself, but even though I no longer work there, just so you know. So since 2008, our mission has been to accelerate developer productivity. We also have a commercial product called Develocity, which is the first developer productivity engineering integrated solution that works with Gradle, Android, Maven, Bazel, and Scala/SBT. We also coined the term developer productivity engineering. We have a developer productivity engineering handbook. We have a DPE summit in San Francisco, which is happening next week. We also do some shows online, the DPE Lowdown, the DPE Showdown, which you may have seen online. We also offer some courses. If you go to dpeuniversity.gradle.com, we have free courses on Develocity, Gradle, Maven, and a lot of them are very beginner, just learning how to do tasks and things like that. Actually, which brings me to my next question. How many people here are advanced super power Gradle users? Okay, we got a bunch of power Gradle users in the audience. And how many people are beginner Gradle users? Okay, we got a bunch of beginner. That's great. This talk is actually for everyone. So I'm glad we got a wide range of people here. So yeah, a little bit about the Gradle build tool. It's obviously an open source build tool, and it's one of the top 20 open source projects according to TechCrunch. And it's also the default for Android development, which you may already know. And it's one of the most popular build tools on GitHub. So what are the challenges in Gradle? You might be surprised to learn. But anyways, the good thing about Gradle is it's very flexible, extensible, and adaptable to complex requirements. You can do very complex things in Gradle. And that's really appreciated by advanced users. However, being super flexible comes at a cost, which is a significant learning curve. And also that Gradle projects look completely different than one another. So that means there's a lot of ways of doing the exact same thing. So yeah, we know this and we want to overcome these challenges. In the past, there's been, and still now, some recommendations on improving on having very complex builds is we recommend using Kotlin DSL to have a good IDE experience. We recommend keeping your build logic in plugins to make your build.gradle files declarative, giving convention plugins meaningful names, keeping your build script simple, without conditions, without for loops, without basically build logic in your build scripts. But even if you do that, yeah, there's still some challenges, which is it can still be very hard for non-expert Gradle users to understand the logic. And there's no consistency between ecosystems and even projects in the same ecosystems. That is, if you're making a JVM Gradle project or backend Gradle application, it can look completely different than an Android application. And that makes it hard to understand Gradle because you might only know it in a specific domain. There's also no enforcement mechanisms to keep build files declarative. You might go and refactor all your build files, everything's declarative, everything's amazing, but then someone goes and adds some build logic. And arbitrary code and build scripts limit what tools can do. What I mean by that is if you write logic in your build files, then that makes it hard for tools to just parse and understand the logic that's in your build.gradle files. So what is our approach to solving all this? It's called Developer First Builds through Declarative Gradle. And it's a fundamental advancement in the user experience for software developers using Gradle. It's also just historically, Gradle as a company, we know we've prioritized the needs of advanced users and large projects over the needs of new users, but now we're shifting the focus back to new users. Yeah. So, Declarative Gradle. Before we dive into what Declarative Gradle is, just some background information to clear up. So, we're working on Declarative Gradle with multiple teams, both within the company of Gradle. We have the DSL team, the software team, and the IDE team. And we're also working closely with the Android Studio team at Google, as well as the Android Gradle plugin team. And then we also work together with multiple teams at JetBrains. Speaking of JetBrains, you may be aware of Amper, which is an experiment by JetBrains with very similar goals as Declarative Gradle. Amper uses YAML for configuration. It's currently focused on Kotlin multi-platform, but of course we'll bring other types of projects aware, and it works well with JetBrains IDEs. So who are the users of developer first builds? I asked the question earlier, who's a superpower Gradle user and who's a new Gradle user? So the way we think about the users is we have software developers, who are the majority of most software teams, who are developing the software, and they just want to improve the software by shipping features and fixing bugs. And then we also have build engineers, who are the people who maintain the build, right, make developers productive. And some teams, right, people switch off, they play different hats. You might have that one Gradle expert in your company. But yeah, those are the two different users that we've defined. And then another thing is we have the software definition. Software definition is what needs to be built, right, the kind of software, the language, the target platforms, the compile SDK version in your Android build, the dependencies you have, compose, Java tool chains, quality checks, those types of things. And that's different than the build logic, which is how the software is built, right? Capabilities, integrating tools, and supplying conventions to the software definition itself. So how those conventions get supplied to the software definition is the build logic. And this is how we're thinking about the separation, right? So software developers work with software definitions, and build engineers work with build logic. So yeah, and then the mission statement for the developer first builds is Gradle Build Tool is an open source build system that automates the process of building software of any type, size, or complexity in a fast and reliable manner. What sets Gradle Build Tool apart is its elegant and extensible declarative build languages that enables expressing any build in a clear and understandable way. And the second part is bolded because many of you might say, well, Gradle isn't any of those things. But that's what we're working on. We know this. Gradle is extensible, which is great. But is it declarative? Not yet. Is it clear and understandable? Not yet. So yeah, those are our principles. I'm going to just give a disclaimer here. These are all experiments. They require special Android Studio nightly builds. Some of the IDE features are going to be demonstrated out of the IDE with a special tool. And these are, of course, prototypes. They're changing all the time. They're not ready for production use. But we really, really want your feedback. That is why we're here presenting it to you. We want to know what you want out of Declarative Gradle in order to make it work better for you and the community. And with that, I'm going to hand it over to Inaki to dive into software types.
Okay, thank you, Nelson. So before covering software types, I'm going to tell a story. Okay. Let me go first to... Perfect, sorry guys. So this is going to happen a couple times more during the presentation. Yeah, so I'm going to tell you the story about two Android developers that joined the company on the same day. And one of them is going to work with KTS in a model, and the other with this new experiment that we call Declarative Configuration Language. Okay, I'm the first developer working on a KTS file, and my manager told me that, well, I need to use my awesome skills working with Compose, but first I need to create a new model. And this new model needs to use a namespace and, something about the build type. Okay, so the first thing that I'm going to do on Under the Studio is, well, so I'm good in Compose, but I don't know about Gradle. What about the autocomplete? So let's see if it helped me. False, plugins, Android, Gradle, plugins, components. What should I do, right? This is the first time that I'm seeing a build script. So obviously, plugins could be, right? Or something like apply. I have a German package here. I don't know what it is. So, and then let's see. So false, no documentation found. Plugins comes from Kotlin DSL. Android, no documentation. Gradle, yeah, I'm working with Gradle. So, but it comes from the API project. Val, I don't know. So, okay, but don't be picky, Inaki. So, I mean that you're working with Gradle and you know that Gradle is extensible and you need to apply plugins. Fair enough, right? So let's keep that. Okay. Okay, I am applying plugins and I told my manager, hey, Nelson, so what should I apply? Nelson told me, you need to use a convention plugin the domain experts, core and platform team have defined with the build engineers that is called feature, something feature. Okay, cool, perfect. So I'm going to implement this plugin. And Nelson told me, wait, you cannot use ID. Because in the plugins block, if you are using an entry of version catalog, you need to use the alias keyword. Yeah, okay, so what's the deal? No, you need to use the same ID, but with alias. Okay, let's see. I was trying just to work on my model. Okay, libs, plugins, now in Android, feature, perfect. Now I can work, well, I have something in my project, right? So the plugin that I'm using. Okay, so what's next? My manager told me that I need to use the namespace. In the context of the Gradle plugin, I need to set up a namespace, right, in the project. So again, what I have is false namespace, libs namespace, plugins namespace, no, I used before, ball dependencies, Android plugins, components, apply, the German package again, all projects, artifacts, and everything is coming from different packages, right? Project, or Gradle API, Kotlin DSL, so it's not clear. But again, so I've been working with Android maybe 2 years, and I know that I need to use the keyword Android. But Android library or Android application? No, just Android, okay? So I mean that it is what it is, so. Okay, Android, and let's see. So Android, well, doesn't resolve anything. So that means that maybe I need to sync, right? That's something that my colleague told me all the time. If it doesn't work, try to sync. Okay, I'm going to sync the project, and now I have one problem that is familiar because Nelson told me, hey, you need to specify the namespace, and looks like that the namespace is not specified, but the Android is there. So I understand that should be here on namespace, what I have, name, display name, archives name, well, whatever. So I mean, they're going to do an act of faith, right? And I'm going to name it like this. Perfect. So now looks like that is compiling, and I have now highlighting the code, and I have my configuration of an Android, right? An Android extension. So additionally, manager told me that I need to disable the minify, so the minification of the array task, and that's something from the build type. Now I'm starting to see closer in my IDE what I need, so it's going to be the build type. Perfect, I know that it's release. Release build variant, by the way, is not a concept from Gradle, it's an IGP concept, okay? So, release and minify, let's see, it's minify enabled, false. Okay, so this is, well, I'm done. I finished the configuration of the project, right? I didn't start working on my feature with Compose. And now let's see how would be this cover of the project configuration with DCL. So, yeah, exactly. So I'm in a DCL file. declarative configuration language. Sorry about that, that's something that we will see later. And I'm going to do the same operation, so let's discover what I can do. And the first thing that I'm seeing in the IDE are the software types or components that I have available to apply in the project. So, and now it's very concise. I can use or I can implement an Android library or an Android application, a Kotlin JVM library, or a Kotlin JVM application, and that's something that I'm familiar because my manager told me that I need to work in a feature model that is an Android library. Let's work on this Android library. So, and what else? What I can do additionally? The namespace, that's the same thing that my colleague was telling me to do, right? And what else? The build type, right? Everything is there. So I can see that the different configuration allowed for this specific plugin or software type, that's a term that we are going to see later, everything is here. And I don't have the German package. So this is everything about the available configuration that I need in the project. So I'm going to use the build type. There was like the release build. What else was the minification? Enable false. And yep, so I achieved the same configuration with declarative configuration Gradle without understanding a single thing of Gradle. I don't know what is a plugin. I don't know what is a convention plugin. I don't know what is a version catalog. I don't know what is a plugins block. I don't know what is an Android extension. I just want to work on my feature. I don't need to be a Gradle expert or game familiar. And that's the goal that we want to achieve with declarative configuration language. So if we compare both files, that's quite similar, right? So, but the goal of this configuration language is not to have like more or less lines. It's more about how we can describe the configuration of build files. Okay, perfect. So I need to go back to stop mirroring. Yep. Okay, but now it's here. Oh, I need to arrange. Yeah, right.
Click built-in display. Yeah.
Thank you, Nelson, again. Okay. Okay, so during this showcase, right, we were referring software types. And that's like two main components of this new configuration language. There are two experiments. And the first one, it's called software types. A software type is a higher level abstraction that hides the implementation details of the build configuration. So it provides to developers a model that represents what can be built in the project and allowing them to focus on development. So what is required to build a project? This is defined by the domain of the project itself. So if I'm an Android application, I would need an Android library or an Android application. If I'm working in a Kotlin JVM library, I need a Kotlin library. So the domain is that. So it's not about an Android extension or Gradle plugin, it's what I need. In terms of Gradle configuration, you can think on software types as an evolution of convention plugins and project extensions. There are a couple of principles that apply, like no access to low-level Gradle implementation details, like tasks, configurations, and eliminating the need to apply plugins explicitly in the build configuration files. As well, you can use software types in your Groovy DSL and Kotlin DSL. Before, we were seeing with a DCL file, but you can use the same with Groovy and Kotlin DSL. This concept of software types may seem abstract, but Gradle already offers prototypes for Kotlin, JVM, and Android, where software types have been created for those ecosystems. The idea is to wrap the existing plugins and guide the configuration. So, okay. So let me show you a little bit more about the software types. So what we saw before in the example of this Android library, right, that represents a software type. So a software type is what is the representation of the model. How would be the configuration? For instance, in my software type, I'm defining that I need to configure dependencies, I need to configure build types, and I need to configure protobuf and prowar files. So far, so good, right? You have a software type, and you are defining what is needed. This type, additionally, is extending from Android software, and this Android software is the common shared configuration between the different software types that belongs to the Gradle plugin, Android Gradle plugin, library and application. By the way, this code is available on Gradle, Declarative Gradle, and there's like the public prototypes that we have today. And finally, I want to show you how this is connected to the Gradle runtime. At the end of the day, a software type is a plugin too that is using the software type annotation to define what kind of model we are building. And in terms of the implementation, you can see that what we are doing here is just applying plugins too. So in my software type, in my model, in my domain, an Android library is a Kotlin library too, right? I'm using Kotlin with my Android project. So I need to apply first the com.android library from the Android Gradle plugin, and I need to apply the Kotlin Android plugin from the Kotlin Gradle plugin. So the idea can go further because we have seen many different projects that they have different models grouped by entities. So instead of defining a software type like Android library, we can define a software type by the entity or by the layer. I would have a feature software type, I would have a core domain software type, and so on, increasing the extensibility of your domain in your project. And yeah, so another, yeah, perfect. By the way, so the Android Gradle plugin as well is going to include in future versions as well some software types. So that's cool. Okay, another interesting concept of the software types is the implementation of reusable conventions. This allows you to specify common configurations for project or dependencies at the top level settings of the Gradle file. And then you will reuse this configuration. So something like, okay, you have in your settings.gradle, you are using this software type that is called Android application. So you are defining that the default values for the compile SDK is 34. So later in your module, like in this case it's a KTS file, you don't have to implement or you don't need to implement the compile SDK. Okay. So, okay. Perfect. What we have seen now in terms of software types, honestly, resembles what you can achieve today with convention plugins. That's true. So what we have seen in solutions in our team with different companies is a discipline hierarchy of convention plugins with some companies where they define the requirements of the build based on layers, for instance, as we saw before. And it works well, it's amazing, and it's elegant. But still, we cannot enforce the correctness of the build script configuration file. And that's something that we saw previously in our demo, right, that we were so declarative. So we are missing something here. And that part is the second part of the experiment that involved a configuration language called Declarative Configuration Language. The extension of this new language is .gradle.dcl. Obviously, it's purely declarative, no conditions, no loops, and only one way to do one thing. It's a small subset of Kotlin, so we are familiar with the syntax, but still, it remains the Kotlin's best feature. A well-written DCL is similar to the KTS, something that we saw before. It does not rely on the Kotlin compiler, something important as well, and of course, DCL is a configuration language, not a programming language. So parsing and evaluating the configuration files is inherently faster. So the build tool team has performed some benchmark performance, right? So, but we prefer to don't share because we are still on this experiment phase, but the results looks promising. Why? Because it's a configuration language. So the Kotlin compiler is not compiling KTS files, or the Gradle runtime working with Groovy. So our results are faster, but please take these notes as a grain of salt because this is an experiment and the parsing and evaluation will become more complex, and we need to share the result to be sure when we are sharing the results. But honestly, what we have seen is like faster, and we love it. So it was like awesome. Okay.
That is, it's faster than Groovy and faster than KTS.
Exactly, faster than Groovy. Okay, and now I want to show you, okay, another example, right, of the DCL file. So this is the Now in Android project that was forked by Gradle, and here we are doing some testing with software types and DCL files. So this is a real project, I would say, if you want to say Now in Android is real. And the first thing that notice, right, is for core domain, is that we are not using, we are not applying plugins explicitly. So that's something that we saw before. The namespace, we are using what's before, and dependencies. The dependencies block we're seeing here is within the Android library block. But well, so let's continue. Now we have a new configuration block called testing that contains dependencies as well. And let's stop for a moment. Again, as a user, we have been working with Gradle like 10 years. If you need to use test dependency in your code, you're going to use test implementation, right? But why? Well, because it's a configuration that implies that you need to use the compile runtime class path of the dependency that is not in the main compile class path, whatever. We are using test implementation because it's something that we saw in the previous code, in the previous file, and always has been like this. The plugin author, in this case, has chosen another way. So instead of having to rely on these magic names that have a sense in terms of configurations, but not as a user, why we don't define in the software type a new block of dependencies where you can declare the implementation dependencies without worrying about if it's a test implementation, under test implementation, and so on. Why, if Jacoco, that's something that is implicitly related with testing, should be declared outside this testing block? Why I'm not putting it all together? And I think that, honestly, that's beautiful, right? I think from the user perspective, and from user, I mean the Android developer, it's much easier to understand what he needs to do of Gradle terms without understanding if it's a test implementation or how to configure this Jacoco extension that needs to be applied on the plugins block. So, because that you get the idea. And of course, we have autocomplete, of course, with the different parameters, right? So that we want to set. So this project is available on GitHub as well, so in case that you want to take a look. And finally, in terms of tooling, what I want to show is, okay, something that, one of the reasons why Gradle at the end of the day is not only in terms of having like a new language or new abstraction in terms of software types, what is important is the integration with tooling. So Excel in terms of tooling with Android Studio, with JetBrains, with all the IDEs. And with this approach, another positive side effect is that we can consume and produce those configuration schemes. Because at the end, the configuration is going to generate a scheme, and we can consume and produce those files. And this has, Nelson was telling me before, right, a real impact on the Android IDE, on the Android Studio IDE, where we can apply refactors based on those configuration files, and we don't need to start or wait for syncing and these kind of things. So, yeah. Nelson, help me.
So wait, how do you stop Mary?
Okay.
Use as
Stop,
Mary.
right?
Oh, yeah,
Perfect.
yeah.
So we have this tool that is called Gradle Client. It's outside of the scope of this presentation, but just let you know. So this tool is using the Gradle tooling API. What is simulating here is what an IDE could do, right? Okay, so we have connected now in Android. That's the declarative project that I was using, my JDK, Gradle user home, and so on. So I'm going to see the scheme of my DCL configuration defined by the different software types. And here, what I have is the complete description of what is a configuration file for the Android application software type. I could explore even different software types, and what I have is again the scheme, and now I can enforce some kind of linting or enforcing versions, whatever. So the same for the Kotlin library. And this tooling as well allows you to have mutations. So you can mutate as well the code that you have. For instance, if I go to the declarative documents, what I have here is, well, the content of the DCL file. But let's do an exercise, and let's go to the library that we were working before. And what we can see is like the namespace, the build types, the release. So thanks to this tooling API, where I can update the values here, so as well. And that means that my project should be updated too. Well, whatever. Oh. Well, so you get the idea, right? So I mean that again, because we have the scheme, because we can parse and consume the data, we are able from the IDE to start having like a more advanced mechanisms to apply refactors or what kind of thing that you can think of that. Perfect.
Where are we? Okay. So, with that, we're on to what is next for Declarative Gradle. So the first early access preview was released in July. With our blog post, we got feedback from the community, which we very much appreciate. We're doing a second early access preview in October with Android Gradle plugin integration. We're working closely with Google on this. And we'd love another round of community feedback. I'll show you how to do that at the end of the talk. And then we're expecting a third early access preview at the end of the year. The content will be based on the feedback from the second early access preview. Yeah, there's a lot of things, obviously, that aren't finished yet. This is very much an early access preview. It's not a beta, it's not an alpha, it's just a preview of the features. But yeah, we're working with Android and Google to get the Android Gradle plugin extensions into the DSL. Some things kind of just work out of the box, as you've seen, but other things we need to add features both on the Android Gradle plugin side and the Gradle side to get everything working. Another big thing is composability and extensibility. So basically mixing in software types, right? If you are using Compose and Hilt, which are different Gradle plugins, as well as the Android application, Kotlin, things like that, like how all that stuff works together, because in the Gradle world, plugins add extensions to other plugins. So how that will be modeled with software types is kind of a constant evolution, right? And then migrations is something we're going to be working on. Yeah, our team is also working with IDE teams, Visual Studio Code, and yeah, Gradle Init will also support generating sample builds with the DCL. But yeah, the important thing is the call to action for all of you. First is read our latest blog post. Go to declarative.gradle.org. That's actually the entry point to all of this. If you go to declarative.gradle.org, there's a link to the blog post. There's a link to all the samples, the project that Inaki was going through earlier. That's all there. They're now in Android. There's Android example builds, Kotlin example builds, all that. Join our community Slack and join the Slack channel Declarative Gradle. Share your thoughts and use cases with us and fill out the developer survey. So I'm going to post a giant QR code now. Take that link. That's the survey. It's also linked to from declarative.gradle.org. And yeah, we want your feedback. You can tell me that it was all super complicated, it was all too easy. We want feedback not just from build engineers, but also from software engineers, right? That is the people working in Gradle code bases. So don't feel like you have to be a Gradle expert to fill that out. And with that, I want to say we're at the Gradle booth here if you want to talk to us. And we also know that I'm sure we have a lot of questions. So I think we have time for maybe a couple questions. But yeah, thank you very much. And yeah, time for questions.